Okay, we're moving now into the second part of your first unit. So we're going to begin looking at the graphs of trigonometric functions, and in particular creating the graphs for y equals sine theta and y equals cosine theta. And before we do that, we're going to have a look at something called the unit circle, because we're going to make use of the unit circle in order to create the graphs in question. So the unit circle is the circle centered at the origin with a radius of 1. So on our little diagram here, we can label -1 and 1 on both axes, x and y. And it says let P be any point on the unit circle. So let's say this is point P. Now, if I create the terminal arm associated with point P, so we'll call this angle theta, and the right triangle associated with that angle, then of course the side length of our vertical side would be y, this side would be x, and this is looking very familiar from a couple of lessons ago, other than that since this is a unit circle, the radius here is always going to be 1, whereas before the radius was not always 1. However, what we do know from before, so let's say recall, is that sine theta is equal to y over r, cos theta is equal to x over r, and tan theta is equal to y over x. Now because in the unit circle the radius is 1, I'm trying to write here r equals 1, then we can reduce these down and say that sine theta is equal to y, because it would just be y over 1, and cos theta is equal to x. Now what does that mean exactly? Well, that means that for any point on the unit circle, the terminal arm would form an angle with the positive x-axis, and the coordinates of that point P correspond with the cosine and sine values for that angle. So the x-coordinate in particular would be equal to cos theta, for whatever that angle would be, and the y-coordinate is equal to sine theta. Now what that allows us to do is to fill in the coordinate points for all of the points rotating around the unit circle for our special angles, because in order to do this we will make use of our special triangles. So let's actually just draw sort of a quick reference of those special triangles here in your note. Okay, so we had our 30, 60, 90 triangle with side lengths of 1, 2, and root 3. And we had the 45, 45, 90 triangle, side lengths 1, 1, and root 2. So now we have those handy to refer to when we're filling in our unit circle. So first of all, having a look at all of the angle measures as we rotate around your circle. So here we would have, well, 0 degrees and 30 degrees and 45 degrees and 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees, 210, 225, 240, 270, 300, 315, 330, and a full revolution of 360 degrees. Okay, so what we said was the coordinates of each point around the circle will correspond with the sine and cosine values of the angle in question. So, in other words, looking right here from your note, the coordinate of each point. We'll find the x-coordinate by finding cosine theta and the y-coordinate by finding sine theta. So starting with 30 degrees and using our special triangle, we know that the cosine of 30 degrees is root 3 over 2, which means the x-coordinate at this point is root 3 over 2. And the y-coordinate will be sine 30, which is 1 over 2. Now, we also know that those will be the ratios for every angle that has a reference angle of 30 degrees. That is all of the angles related to an angle of 30 degrees. So, for example, then I can fill in the coordinates of this point over here, because the ratios will be the same, except that now we're in quadrant 2 where only sine is positive. So our point will be negative root 3 over 2, 1 over 2. And of course that makes sense because in quadrant 2, x is going to be negative and y will be positive. Okay, now in quadrant, in quadrant 3, the related angle for 30 degrees will be 210 degrees. So now I can fill in this point along the unit circle. And in quadrant 3, tan is positive. Actually, let's go ahead and fill in the cast rule on here just for quick reference. So cosine is positive in quadrant 4. They're all positive in quadrant 1. Sine in quadrant 2. And tan in quadrant 3. So now we have that for quick reference. Okay, we were saying the point along the unit circle coordinate corresponding with 210 degrees then will be negative root 3 over 2, negative 1 over 2. And finally, in quadrant 4, we have a related angle of 330 degrees, where cosine is positive, so our point will be positive root 3 over 2, negative 1 over 2. So now we have filled in 4 points around our unit circle. Now we will move on to an angle of 45 degrees next. Let's grab a different color here. All right, 45 degrees right here. Okay, so cosine for 45 degrees is 1 over root 2. Sine 45 degrees is actually also 1 over root 2. So the corresponding point on our unit circle will be 1 over root 2, 1 over root 2. Now we'll go ahead and fill in the point for all of the related angles for 45 degrees. So in quadrant 2, we will have at 135 degrees the point negative 1 over root 2, 1 over root 2. In quadrant 3, 225 degrees. X is negative here, of course. Y is also negative. Okay, only tan is positive in quadrant 3, so both your sine and cosine ratios will be negative. And finally, an angle of 315 degrees. We will fill in 1 over root 2 and negative 1 over root 2. Okay. Now we'll go back to the 60 degree angle in quadrant 1. Let's fill in our values here. So the cosine of 60 degrees is 1 over 2. That will be our x-coordinate at that point. And sine 60 is root 3 over 2. So that will be our y-coordinate. Now we can fill in the points along the unit circle for all of the related angles. So at 120 degrees, I'll have the point negative 1 over 2, root 3 over 2. At 240 degrees, I will have the point negative 1 over 2, negative root 3 over 2. And at 300 degrees, I will have the point 1 over 2, negative root 3 over 2. Okay, and the only points left to fill in around the unit circle are these ones here. At 0 degrees, we would have the point 1, 0. At 90 degrees, I would have the point 0, 1. Remembering here that the radius of this circle is 1. Okay, so that's where I'm getting these coordinate points from. At 180 degrees, I would have the point negative 1, 0. And at 270, I would have the point 0, negative 1. And so we could color code those terminal arms as well if we want to. Okay, so I have now filled in several points around the unit circle, the coordinate points at those specific angles. And I can now use that to create the graphs of sine and cosine. Now, in order to do that, we are going to take these exact values and fill them into the chart in your note, these charts here, by placing the exact value in column 1 and the estimated value in column 2. So for example, for y equals sine theta, the exact value of sine 0 is 0. So the estimate would also be 0. The exact value of sine 30 is 1/2. We'll write that as 0.5 in the estimate value column. The exact value of 60 is root 3 over 2. We will write that as 0.87, and so on. And what we're doing here is attempting to create some points that I can use on my graph, because it's a little bit difficult to graph values like root 3 over 2. Okay, so we're attempting to convert these to decimal values simply so that I can make graphing these functions a little bit easier. Okay, so we'll continue on and fill in the table. And of course, I'm getting these values directly from the unit circle, okay, looking at the y coordinate for each point corresponding with the angles listed here. So for example, to get the exact value for sine 300, I'm looking at 300 degrees on the unit circle, and I am looking at the y coordinate at that point. For 330, look at the y coordinate, okay, at 330 degrees, and you'll see that it is negative 1/2. So that's where these values are all coming from. Okay, now we'll do the same thing for y equals cosine theta. So now we would be looking at the x coordinates of all the points on the unit circle. So for example, the exact value of cosine 0 is 1. And so on. Cos 60 is 1/2. Cos 90 is 0. 120, negative 1/2. Okay, and I'm doing this rather quickly just for the purposes of the video, but I would encourage you, okay, to have a look at your table, your unit circle, in comparison to the table, and make sure you understand where I'm pulling these numbers from. All right, but in the second column, I'm simply using a calculator, or I did use a calculator, to get the approximate values, in particular for the root 3 over 2. 270, 0, 0, 1/2, 0.5, cos 330 is root 3 over 2, and cos 360 is 1. Okay, we're going to plot these points now onto the graph to create the graphs of y equals sine theta and y equals cos theta, but at this time I'm going to have you switch over to video 2.